Okay, now I'm going to run a rotovertor motor and put a scope on it and look at the phase shift going into the motor from the grid. The phase shift between volts and amps from the grid, the 120 volt, 60 hertz AC grid I have here in Seattle. Inside this blue box is a rotovertor motor that's pretty noisy. I put it in there. It's got ceramic bearings with no grease in them at all. So right now I'm running this at 70 milliamps. I have the meter in AC 20 amps. I tried some run caps and a 4 UF run cap right here was the best. It draws twice the amps if there's no run cap at all. Before I left to Belarus about 5 months ago, I had this at 30 milliamps, not 70. It may have been a different motor, but right now 70 is okay. Just do 70 milliamps. Input's pretty good at 120 volts. And so I just want to see what the phase shift looks like. And so I will do that. 1 minute. Okay, I'm running the rotovertor motor without a run cap now. And the one I'm moving is current. That's the amps through that 1 ohm resistor. You want to get it so that it's right in the middle, so like there and there. So the zero line goes right between the height of the, so right there, see that one's up there. This one's down there, so that looks pretty good. Now the phase shift is going to be the distance between, here's the current and here's the voltage. So that's the phase shift right there. Or you can say it is over here. So that's the phase shift going on. And what you do is you go one cycle, like the voltage is from here to here. And that's 360 degrees. That's one AC cycle. Then you count how many, there's 5 small spaces in each square, and you count the spaces from here to there. And then you take 360 divided by that many spaces, and that'll tell you how many degrees is every small minor division, they call them. I just call them spaces. For every square, there's 5 little spaces down here. So 360 degrees divided by how many spaces that is will tell you how many each space, how many degrees there is. if you count, this looks like about 4 spaces. So let's say, just guessing, let's say it's 20 degrees per space. And so that would be 4 times 20 is 80-degree phase shift right here, if so. Okay, so I'm gonna change the run cap. I'm going to put in that run cap that gave it 70 milliamps input. Right now. Now look at that. See, current went down quite a bit, but it's not very smooth sine wave. You know, it dropped a lot of current. So I'm going to try a tube. This is a 2 UF cap, not a 4. And you see there's more current, but it's not such a bad shape anymore. And it still has a pretty big phase shift here. Let's try a 5 UF. This is 5 UF. See? Wow. So, and let's try 1 UF. Okay, this is 1 UF. So there's an example of what the phase shift looks like feeding a rotovertor motor coming from the grid. The scope is between the grid and the motor input. So I guess that's good enough. It's fairly boring. Conclusion, I would say, is that you have the lowest draw, but not such a great looking sine wave when you use a 4 UF run cap. Now, well, you know, I'm going to keep going here. Watch what happens when I rub a stick on the shaft here. I'm not going to be able to see this, but I'm just going to do it. So that was really pushing hard on the shaft. And that's what happens when you add a load to the shaft. Is the sine wave will go as it did. And you need to change the UF value of the caps when you do have a shaft load going on. It'll be a higher UF, like 15 instead of 10 or 20 instead of 15. And that was quite a bit. I could not stop it. I don't think I can stop this with my hand. It's quite a bit of power there. So I'll call it a video now. And thanks for watching.